Which of the following condition does not ensure the convergence of a real sequence an? Four options are mod of an minus an plus 1 tends to 0 as n tends to infinity. Summation varies from 1 to infinity. Mod of an minus an plus 1 is convergent. Option C is summation n an is convergent, and sequence options 4 is sequence a2n 2n plus 1 and a3n are convergent. Four options four options are given to us, and we have to find which one is correct and which one is not giving the assertion about the convergence of the sequence. Means that options we have to find which cannot imply the convergence of the sequence. So option A is given to us, mod of an minus an plus 1 tends to 0 as n tends to infinity, and not ensure the convergence of an means not imply limit of an equal to L and L not belongs to R. Limit an equal to L and not belongs to R, it means L is infinity type, means positive infinity or minus infinity, whatever. I'm not interested about the L, but limit of an will not be a real number. So there are many sequence or function which never converge to a specific number. Means if very well known function is exponential function, and its reciprocal type function or its reverse function is as logarithm function. Both are not converge to any specific number. So our idea, uh, just on the behalf of this, if you consider an equal to log n, then mod of an minus an plus 1 equal to log n minus log n plus 1, and apply the log property, log a plus b, but here is minus, so it will be log n upon n plus 1. Take n as a common, and this will be log of 1 upon 1 plus 1 upon n, and if you take limit, then this one will go to 0, so it will be log 1 and log 1 is equal to 0. So this condition is fulfilled. An minus an plus 1 tends to 0 as n tends to infinity, but limit of an equal to limit of log n not belongs to set of real number. This is one example. You can consider another example also as second example. As we want to interested of finding a sequence which is not convergent, it means which is not convergent, and mod of an minus an plus 1 tends to 0, it means if I take a term like this 1 upon in denominator, because this tends to 0, it means in denominator n involved here, so I take root n plus root n plus 1, because n here and n plus 1, so on the basis of this, and these are giving the idea about to consider how to consider the function or sequence. And this will be equal to, if I rationalize it, root n minus root n plus 1 divided by root n square minus n plus 1 whole square, and this will be equal to root n minus root n plus 1 divided by 1. So this limit is 0 because of this is 0. So this one is 0 because these are same. These are same. But limit of an equal to limit of root n, as I consider an equal to root n not belongs to set of real number. So this is a second example. So there are more examples or many examples you can search or find out for option A. Now what is second option? Summation of mod an minus an plus 1 is convergent. If a sequence or series is convergent, it's mean that limit of its nth term is 0. If summation un is convergent, then limit of un equal to 0. But converse is not true. If limit equal to 0, then summation or series is convergent. Well known example, summation of 1 upon n. Limit of 1 upon n is equal to 0, but this series is not convergent. It is divergent series of positive term series, but divergent series. What is given to us? Option B, mod of an minus an plus 1. This series is convergent by the above fact, limit of this one equal to 0. Mod of an minus an plus 1 is equal to 0. And you can see here, this is the type of Cauchy criteria of convergence. This is of the type, it's somehow looks Cauchy criteria. Or you can analyze in analytical way as two terms, difference of two terms is going to much smaller and smaller, then this limit will be equal to 0 and the sequence is convergent. So limit of an equal to L and n belongs to R, so it also implying the convergence. So B options is not true here. Option A, our choice, because of that one is not ensuring about the convergence, but this one is our certainty to certainty or insurety about the convergence. So option A is our desired because of not ensure about the convergence. You can see here, not ensure the convergence of real sequence. Now we check option C, summation n an is convergent. Summation n an is convergent. If it is convergent, then same as option B, limit of n an equal to 0. If this limit is 0, it means limit n dot limit an equal to 0. If two function limit is 0, then product limit is also 0. And you can see here, this limit is infinity type, and this one, if it is suppose L, then it is equal to 0. No. How? You should consider this as, suppose this is whatever the number. So this is somehow in definite form, and you have to apply the L'Hopital rule. Then L'Hopital rule gives the limit this equal to 0. You cannot proceed this directly. So this may lead you incorrect answer, or you can stuck here to find out the limit. So apply indefinite form, or you can consider limit n equal to 0. It means limit an plus up to n type. How many times? N times is equal to 0. Then these all an limits should go to 0. You can analyze in another way is like this. So option C is also our, it is giving the surety about the convergence, so it is not our right choice because of, as a statement is saying, not ensure. So option C is our not choice. Now option D is the sequence a to n means event terms a to n plus 1, odd terms and 3n means multiple of 3 are convergent. Here two conditions is given to us, a to n and a to n plus 1, a 3n. This is condition 1 and this is 2 are convergent. Are convergent, then this implying convergence of a. Now we think about it. This is event terms and n is formed by even plus odd. It means all even terms is considered here, and here odd terms, some odd terms, all odd terms, all even terms. This one is all even terms, here all odd terms, and this one is multiple of 3. So this one also comes in odd terms, multiple of 3. It means some term will be odd and some term will be even, like 3 is even, 3 is odd, 6 is even, 9 is odd, 12 is even. So it means half term is even and half term will be odd. So both are mixture. Both are mixture of almost terms of the sequence is coming here. Almost all type sequence term is considered here. So its nature almost depend on it, and this will, if this is convergent, then an is convergent. So it is defined on an, or can I ask a question? We can restrict this condition to another condition. Yes, if I restrict this condition as 2n plus 1 and 3n, this is my one condition, and suppose this is 2n. So I want to restrict this condition. So if I delete this one and I make it n plus 2, then n plus 2, this will give all even terms, and this will gives to even and odd. If n is even, then plus 2 is also even, so it will comes here. If n is odd, then odd plus 2 will be odd term. Then even and odd terms, almost all terms will comes here, and convergence of the sequence will depends on this. So we restricted it. And what is the use or benefit to restrict it? Suppose you are a computer engineer and you want to make a program which predicts some information or some idea, Then if you proceed, suppose you have to large number of data, means a event type or odd type, then your program is, suppose is performing on even and odd, then your program may slow down. So how you make your program efficient and faster? Suppose your program consider one type, almost all single type is considered here. Suppose even your program is considered all even, and another is mixture of some odd and even. If your program will go all odd terms, then your program may slow down, or your program function is make time consuming, maybe time consuming. So you restrict another condition, so it consider only odd, some odd and even terms, so its prediction may depends somehow more powerful, and your program will be more efficient. The power of this option D is you can lead this option to machine learning or make machine faster. So whenever you want to study mathematics, your target should be like that. You have to improve your mathematical skill to develop some technique or relate to its practical life. That way, then your mathematics will give you enjoy and happiness from your inside.